Hello and welcome to another session of Streaming School. Pleased today to be with you in this glorious afternoon. And as ever, I'm joined by my wonderful colleague, Nisha. Morning, Nish.
Morning.
I just got it wrong. I just said it was the afternoon and then I managed to say
morning. Yeah.
Clown school. Absolute clown school. And we're very lucky to have another science session from the wonderful Bucky Yusuf. Hello, Bucky. How are you?
Hello. Yeah, I'm fine. Thank you. Glad it's Friday, put it this way, even though it's the same type of day, but yeah, glad it's the end of the week.
Do you know what I mean? Are you doing a lot of tutoring at the moment and doing a lot of talks and stuff?
Oh, we started back. So this is the first week of the summer term. So it means we started back at school and the lessons are started back in earnest again now. So yeah, starting to get busy again.
Oh, so is your school doing full timetabled lessons every day?
Yeah.
Right. Okay. It's really
and
interesting.
We have meetings as well. We have tea staff meetings in the morning, just like a touch base in the morning and just recap and review how things have gone in the afternoon.
Yeah, it's really, really interesting because so many schools are doing things in different ways now. So it's, you know, I think next time there'll be a there'll definitely be a best practice if, and everyone will have that set.
Well, I'm just chuckling because I hope, God forbid, there's not next time. But what I'm hoping there'll be some opportunities from this and we can actually continue with distance learning or online education using EdTech. So yeah, it'll be interesting to see what happens as a result of this.
Brilliant, 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 brilliant. Thank you. And I'm sure that many people agree with you, actually, because it's definitely going to be an option. We do a lot of teaching at one of our tuition centres. We do a lot of homeschool parents, and, you know, resources like this would just literally save their life. And I guess some parents, you know, would say, well, give them, you know, a bit of option, a bit of decision. But yeah, getting the resources is the key thing. And just sort of teachers like yourself offering your time to help people, as every teacher is at the moment, is just fantastic.
Yeah, no, thank you. I love teaching and learning. So anything I can actually do to support learning, no matter where the student is in the world, I'm there. I'm always happy to help.
Well, you'd be happy to. I don't know if you saw the flag that I sent around earlier today, or the world map, should I say, with all the different countries who are actually viewing various bits and pieces.
No, I've not seen that yet. No, not at all. So I look forward to actually looking at that. And it's great. I think, as you say, if you've got, say, quality resources that can help students learning, yeah, it will always be well received.
Brilliant, brilliant. Well, this is all yours. Thank you so much. Really, really appreciate it. And the floor is yours, as they say.
Okay, thank you so much. So today is lesson 4 or session 4 of chemistry. And for those of you that have joined me beforehand, welcome back. You'll notice that I've got a particular format. So we recap on prior learning. Last lesson, we actually looked at the differences between elements and compounds, and it links to the different substances you've got listed at the top in blue. And what I've actually done is tabled it so you can actually see which elements are, which substances are elements and which substances are compounds. You notice that the compounds, you've got 2 or more different elements that are actually joined together. And at the bottom is an example of one of these simple covalent compounds, ammonia, here. And it's just showing you the intermolecular forces, so the forces of attraction that we've looked at as part of previous lessons. So just a quick recap there. Those of you that have joined before will also be familiar with this quick 5-5. So I think it's really important to look at your previous learning, just to keep it fresh in your mind, in your memory, and also look at how we can actually link it to what we'll be covering today. So there are 5 questions. So if you've got your exercise book or even a piece of paper or a device, just write down questions 1 to 5. And all I want you to do is just have a one-word answer or even a very short sentence for these 5 questions. What's the overall charge of an atom? So question 2 doesn't make sense. I just realised which state of matter should say has the highest kinetic energy, but we'll leave out question 2 for now. Question 3, what's the difference between an element and a compound? Question 4, what is the chemical formula CO2? And this 2 should actually be lower. So if you ever write a chemical formula like this, actually, scientifically, it is incorrect. And it just goes to show that even though I checked this PowerPoint, there were still a few things that got past without me realizing. So what does the chemical formula CO2 tell you? And question 5, which forces of attraction are found between simple covalent compounds? Now, if you are watching this later on, if it's not live, then at this moment in time, you just pause for a few moments. If you are watching this live, we'll just go through the answers. So number 1, overall charge. It's neutral because the number of electrons that an atom has equals the number of protons. The question 2 doesn't make sense, but it should say which state of matter has the highest kinetic energy in terms of particles, and that will be gases. Question 3, differences between an element and compound. So if you joined me last lesson, remember that elements, you've only got one type of atom, they're all the same, but compounds have actually got two or more atoms chemically joined together. The chemical formula CO2, what does it tell you? It's a compound, so there are two elements there, carbon and oxygen, where you've got one atom of carbon joined to two atoms of oxygen. And number 5, the forces of attraction found between simple covalent compounds. Again, it links to the previous lesson. They are weak intermolecular forces of attraction. Now today, we're going to be taking things in a slightly different slant and looking a little bit more about atoms, linking it to elements, the periodic table. We're looking at atoms, atomic number, and atomic mass. The do now activity is just a quick starter. And there are 3 questions related to the image that you see on the right-hand side. And I have deliberately not told you which particular element this is. The only clue you've got is it's represented by a capital C. So what is the atomic number of C? How many electrons does C have? And how many neutrons does C have? This visual big hint is a clue. So the challenge, now if you find that really easy, there's a challenge question. How would you calculate the relative formula mass of a compound? And this image gives you a hint, it doesn't actually quite give you the answer. The keywords you see at the bottom, we'll be using them throughout today's session. So what do you think the answers are for the 3 do now questions? And we're going to pause. We're going to come back to the answers as part of one of the progress checks, just to see what you know. Now, as I said last lesson, the periodic table has got over 100 different elements. An example of that is listed here. And most of those elements are metal elements. If we were to look at one particular element, say like magnesium, and you were to magnify that, you would find that all the atoms are exactly the same. So we call elements a pure substance because there's only one type of atom you actually see, as you can see on the screen here for magnesium. Now, if we were to look at each of those atoms, okay, so this represents the magnesium atom, as you can see by this information here, we can actually, it tells us a little bit more information. And again, you need to have very powerful microscopes, to actually, electron microscopes to actually see. So you have the nucleus here that's actually made up the subatomic particles. So if you were to look at an atom, the smaller pieces, we call them subatomic pieces. Sub means smaller than pieces. So you've got different things here, and it actually, and you've got these black circles here actually represent other pieces of information. Sorry. So it tells you that you've got 12 electrons, 12 protons, and 12 neutrons. And electrons, they've got a negative charge, protons, positive charge, neutrons, negative, 0 charge, no charge at all. Now, some of you might be thinking, not sure about this, this is the first time I'm seeing that. So we're going to break that down even more. Now, whenever you look at the periodic table, you will always see the symbol of the element. In this case, this is helium, and there are 2 numbers, and those 2 numbers tell you 2 different pieces of information. So the lower value number that you have, it's the atomic number, and that tells you the number of positive protons in an atom. Now, because there's no overall charge in an atom, if you've got positive, they must be balanced or have an equal number of negative electrons. Okay, and that's how we represent it here. The 2 positive protons, because there's no overall charge, there's no positive or negative charge by the symbol, it means that you've also got 2 negative electrons with it. And that tells you the atomic number of the element. Now, the atomic mass tells you something slightly different. Okay, so from the visual that you've seen here, it actually tells you the number of positive protons and neutral neutrons that you find in the middle of the atom that's also called the nucleus. So there's 2 pieces of information I've introduced you to, the atomic number and the atomic mass, and they tell you 2 different things. So going back to our do now activity, what is the atomic number of C? Now you should have realized if you look on the periodic table that C represents the element carbon. And as you can see from what we looked at beforehand, the atomic number tells you the number of electrons or protons. So that will be 6. You can actually see them here, 6 electrons. And there should also be 6 protons as well because they balance out. Number of electrons, 6. The number of neutrons is 6. Now I'll pause for a moment. A lot of students think that the number of neutrons that the element has is always equal to the number of electrons and protons, and that is not always the case. You need to actually look at how you can work that out, and the atomic mass gives you a clue about how you can do that. So let's go on to a different progress check, where what I've actually done is broken down visually the number of protons, electrons, and neutrons for these three different elements, Li, F, and P. So using this, I want you to work out the atomic number of Li, for example, and the atomic mass of Li. And you can just structure your answers in this particular way. Now, these are visuals. I haven't done all of the subatomic particles for phosphorus, E, but you've got the main idea. You've got the number of protons there, how many electrons would it actually have, and these green circles here represent the neutrons. If you find that straightforward, I want you to think about the challenge. How could you work out the number of electrons that each element has, and how would you show you're working out? Now again, if you're not watching this live, you can pause for about 2 or 3 minutes at this point. Those of you that are joining me live are going to actually break it down and look at the answers. Okay, so with Li, that represents lithium. And this is how you could structure your answer, just to make it really simple. The atomic number of lithium is, the atomic number, pointing to it here, it's 3. The atomic mass of lithium, the higher value number, is 7. And to work out the number of neutrons that Li has, you just take the atomic number away from the atomic mass. That gives you 7 take away 3, which equals 4 neutrons. And as I said before, the number of neutrons an element has doesn't always equal the number of electrons and protons, and this proves it in this case. Quickly going on to fluorine, same format for your answers. Atomic number, 9, lower value. Atomic mass is the higher value. Take those two away from each other, and that gives you 10 neutrons. And lastly, with phosphorus, atomic number, get the idea now, lower value, 15. Atomic mass, higher value, 31. And the number of neutrons is 31 take away 15, which equals 16. So these are some of the calculations, very simple, that you can actually do, just looking at the periodic table and working out the atomic mass and the atomic number of each element that's actually presented to you. So demonstrate. How would you be able to explain what these 3 terms are? Atomic number, atomic mass, and something we've not mentioned yet, relative formula mass. How do you think you might be able to explain that? That part is a challenge question. What do you think? Again, if you're not watching this live, please pause for about 3 minutes to give yourself time to explain your answers using the correct scientific words. Those of you with me now, we're actually going to look for the answers together. And I've actually given you some examples of elements just to put this into context. The atomic number, as I said before, is either the number of protons or electrons that an element actually has, and they are the lower value numbers for 9 for fluorine, 8 for oxygen, and 11 for sodium. Atomic mass, the number of protons and neutrons in an element. And the relative formula mass, that basically tells you the atomic mass values for every element you've got in a compound. We're going to go on to an example. Now, this is a model to show you how you can actually work out this type of question. So you may be asked an exam question, how many atoms are in a compound? This is an example of a compound because there's more than one element here, actually 3 different elements. And you may be asked to work out the relative formula mass. That's a challenge. Now, to do that, we break it down. So the first thing is, which elements are actually in this compound? H represents hydrogen, capital N for nitrogen, and O is oxygen. So even though there's a 3 by the oxygen, so there are 3 oxygen atoms, the element is still the same. So let's look at now breaking this down to working out their atomic mass. Hydrogen on the periodic table, when you look at it, its atomic mass is 1. Nitrogen, when you look at its atomic mass in the periodic table, is 14. Now, I'll pause here because this O represents oxygen, but you'll notice there's a number 3 next to it. And that basically means that there are 3 oxygen atoms in this particular compound that you see. So you'll have to write down the atomic masses for each of those oxygen atoms to give you the relative formula mass. And to work out the relative formula mass of a compound, you add up each element's atomic mass. And in this case, the answer works out to be 63. Okay? So that's an example of how you'd lay out your answers to show your working out and how you reached your final answer. So over to you. You proceed.
So, sorry, Bucky, you seem to have gone far away. Maybe the microphone moved or something.
Oh, right, okay. I'm not sure what's happening. Can you hear me now, Leon?
Yeah. I think there's just some shuffling at times. So it's cutting the mic or covering the mic. It's happened 4 or 5 times.
Oh, okay. So I didn't realise that. Sorry about that. I hope you can hear me clearly now.
Yeah, now it's fine.
Okay, may just be moving around. So with progress check 3, same kind of thing with these 3 compounds. What are the total number of compounds you can actually see in each of these compounds? And what is the relative formula mass for each compound? And I've given you a hint. Which elements can you see here that you can find on the periodic table? And what is the atomic mass of each element? If you're working in your own time, pause now for about 3 minutes. If you're joining me live, let's continue to look at the answers. So we'll break it down. With the first one, NaOH, sodium hydroxide, we have got sodium, oxygen, and hydrogen. And below in blue are the atomic masses of each of those elements, which gives you the relative formula mass of 40. How does it compare to what you wrote down? Next one, H2O, water. If you put down the atomic masses for that, this tune here means that you've got 2 hydrogen atoms. So 1 for the atomic masses. And for oxygen, it's 16. So the relative formula mass for that is 18. And lastly, calcium hydroxide, slightly different because you've got a bracket around the oxygen and the hydrogen, and there's 2. And what that means is that you've got 2 lots of that represented like this. The calcium's atomic mass is 40, oxygen's atomic mass is 16, and 1 for hydrogen. But because we've got 2 of those, I've written it like this for 2, so the relative formula mass is 74 altogether. Now, this is an example of an actual exam question linking what we've looked at. There have been a lot of explanations on my part, but these form the key fundamentals of your chemistry understanding, and I'd like to see how well you can actually apply it. Now, before we go through the answers, the only thing I want to point out in question part B is this term here, subatomic particles. If you're not sure what that means, it basically means which parts of an atom is this question relating to? Okay, so let's go through the answers here. So this question is about the structure, atomic structure and elements. Complete the sentences. The atomic number of an atom is the number of protons or electrons for 1 mark. The mass of an atom is the number of protons and neutrons. Explain why an atom has no overall charge, and use the relative electrical charges of subatomic particles in your answer. You need to talk about the electrons, protons, and neutrons. Okay, so there is no overall charge. So to say for 1 mark, you need to say, because electrons are negative and protons are positive. And so the number of electrons is equal to the number of protons for your second mark. But as usual, what did you do well? And what you need to improve. So that's a lot of information, as I shared. And please go through the whole video again if there are any of those particular terms that you weren't quite sure about, or you need to make sure that you understand. And as always, as part of the review, what are the key 3 ideas that you need to remember? Which 2 things are you still struggling with? And what is 1 thing that will actually help you next lesson? And I'll end with further thinking. Now, this is because we're going into the weekend, even though we're still on lockdown. I just wanted to share a fun video with you. So Boing Boing Video, strange name, but it's genuinely. They've got a video by They Might Be Giants called Meet the Elements. And you've got 2 things to consider. how many different elements can you spot in a video, and which is the most abundant element that you can actually find on Earth? A little bit of research for you there. Thank you very much. Have a great start to the weekend, and I look forward to seeing you next week.
Thank you so much, Bucky. Really, really appreciate it. It's fantastic. Are you changing your working hours and working patterns as well, Bucky?
Slightly. So sorry, I'm just trying to come out of this and come back on here. Slightly. So I've got a more structured start to the day. So I need to make sure that I am up relatively early morning to get myself prepared for our briefings in the morning, and I've got my lessons up onto Google Classroom for my students. I can actually teach live lessons as well as being around in the background for any students that need to have any questions answered.
Brilliant. And do you think that you what you said earlier in terms of changing the working routine and being able to do more and more just before we came online, do you think you'll do a lot more of that in the future? Do you think schools will adapt to it?
I sincerely hope so, for for many reasons. But one of the key reasons that we have students for a variety of reasons that cannot be in school. So you may have students who are in hospital schools or students who are ill, whatever variety of reasons. So I just think that I really do hope we can actually explore distance learning and how we can actually make it more meaningful so that students can learn whether they're on site or not. And I said this key point beforehand, but I just think it's a great opportunity to see how far we can actually go with it.
And with more and more educators like yourself coming online, I think it's actually going to give birth to a whole new, skill set within it.
Yeah, definitely. It's a great opportunity to just to see, to try something different and just see what type of results and impact it can actually have.
Yeah, I'm really looking forward to this future.
Same here.
God bless you. Have a great weekend.
And, okay, thank you. Take care.
Ramadan Kareem. I hope the first day of fasting
is
going
thank you.
Well.
Yeah, so we'll see how I am on Monday. I may not be as bright and perky, but have a great weekend, Leon.
Yeah, we need the time lapse coffee or time delayed coffee where you can have your coffee but it doesn't kick in till 6 hours later.
If you can invent that, please let me know.
Have a great weekend.
Okay, take care. Bye bye.
See you later. Bye bye. You know what, Danish? I was working out with the fasting, and I worked out that this will be the apex for people. It won't happen like this again for about 25 years, but we'll be doing 22 years, so you'll be doing summer months.
Really?
Yeah, because it moves 15 days every year or 16 days every year. So yeah, it's just it's never the same time. That's why sometimes Ramadan will happen. Muslims, you'll see them during winter, and they'll just be like, nom 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 nom. Like it's dark at 4 o'clock.
Yeah.
Brilliant. But anyway, it's only 5 minutes or 7 minutes to the next lesson, isn't it?
I know.
Brilliant. So yeah, the rest is yours.
All right, cool. So here is the optional task for chemistry today. There is a link to a resource to help you with this. It's which scientists, there are 2 questions, which scientists helped to create the modern periodic table, and which scientists helped to develop our understanding of the atom. So if you want to find out about this, there will be a resource I'll put up on YouTube and on Facebook. If you've missed any lessons, they'll be on YouTube and Facebook as well. And up next, we have our first mindfulness session, which will be
that's going to be fantastic. I'm really looking forward to that one. All right, brilliant. So I will see you in 6 minutes.
Yes.
And I will learn how to switch the stream off properly.